So, good afternoon, everybody. Today we are going to start with the first practical of plastic engineering. Now, plastic engineering is theoretical subject as well as some numericals are there in the theory part. But as far as practicals are concerned, we are not going to perform any experiment on any instrument as such. But we are going to study the design procedures and different parameters of the mold. So as per the syllabus, we have 6 experiments and one is industrial visit. So you know that in this pandemic situation, we are dealing all on online mode. So I will try at my level best to explain you the concept, whatever are there for this practical through the online mode. So let me tell you the list of experiments which we supposed to study for the subject plastic engineering. First experiment is a study of fundamentals of mold design. So what are the different fundamentals for the mold design are used? So that is theoretical part. Then we are going to study, or the contents of this experiment are different types of molds, then different types of runners and gates, and how mold operates. So generally these fundamentals are covered in experiment number 1. Then experiment number 2 is injection mold die design or simple component. Now as far as unit number 4 is concerned, in that unit number 4 we have studied part design, and here component drawing will be given to you and how die will be designed. So that design steps I am going to explain you in experiment number 2 for the injection molding die. Then design of compression mold for simple component. Already this is part of unit number 5, which I have started in theory classes. Already we are at the same, and there the parameters of compression mold was explained by me, and then we are waiting for one case study. So similar one case study I will take in theory, one case study I will take in practical. So that is this design of compression mold for simple component. Then design parameters of blow mold. Fourth experiment is design parameters of blow mold. So blow molding is used for making number of components, such as the best application is water bottle. So what are the design parameters for it? That is covered in experiment number 4. Then fifth one is design of plastic parts. This is already similar to experiment number. This is already similar to unit number 4, which I have taken as a case study in unit number 4 during theory hours. So there different component I will take, and we will take one more case study. Then sixth one is case study on mold manufacturing. Case study on mold manufacturing means, so mold is made by usually steel, cast iron or any non-ferrous alloys. So how these molds are manufactured? So you are mechanical engineers, you have studied manufacturing process, you have studied machine tool and processes. So mold is usually manufactured by casting, maybe it is then machined on the machining centers, so that it will give good quality of surface finish and good strength. So these are the 6 experiments covered, which we are going to cover in plastic engineering. Now, as far as industrial exposure is concerned, there will be one industrial visit. But unfortunately, due to this pandemic situation, we are not able to visit the industry. But it is my humble request, whoever will get time, if you are nearby, maybe in Tembur area, there is one plastic manufacturing plant. In Kolhapur, there are many plastic manufacturing plants. So you can see these machines if you get permission from the industry, and you can visit at your own. Already what you are going to see in the industry, that already I have shown you in the videos. Okay, so same thing physically we can see by going in the industry. But one more additional thing, by going in industry we will come to know how actually the parts are manufactured, what is the turnover, how the die is fitted, how closing opening of the dies, how the maintenance of die is carried out, etc., etc. So this will be the 7th experiment. So today we are going to deal with experiment number 1, that is fundamentals of mold design. So here I am going to show some figures and pictures. What are the contents of this experiment number 1? So you can write the title, Study of Fundamentals of Mold Design. 1 minute, I will share the screen. So I hope this screen is visible to you. I hope this screen is visible to you. Title of experiment is Fundamentals of Mold Design. Fundamentals of Mold Design. Now, what are the contents of this experiment and what is covered and what is the outcome of experiment number 1? So, outcome of experiment number 1 is, see, every time whenever I start any of the bit, any of the chapter, any of the experiment, I always tell outcome. You always you have to remember what you are going to study, what is the outcome of it. So experiment number 1 is, at the end of experiment, student will be able to classify the different types of molds. Student will be able to study the different types of runners, gates, etc., etc. Now, after end of this experiment, you will get an idea how mold operates, what are the different types of molds, then what are the different types of gates, what are the different types of runners, etc., etc. That's why the title of experiment itself is Study of Fundamentals of Mold Design. Now, as we know that mold is one of the important element in the plastic molding process. Not one of the, it is the important. Whatever parameters, whatever parts are there out of the process, mold design is the important part. So injection molds are determined by number of factors. Which factors are there? Plunger diameters, plunger travel, heating capacity. Plunger means, you know the difference between this this piston and plunger. Plunger is having little more length than piston. So plunger travel, heating capacity, and mold is probably most important element, I already told you. And primary purpose of mold is to determine the shape of molded part. So what shape you have decided, that will be decided by your mold shape. Now, see, mold means, don't consider that there is a cavity. So one half cavity, another half cavity, and just simple as in casting we have seen. No, not that way. See here, I will explain you the mechanism of making of the component in the injection mold. Just see the figure number 1A. This complete is mold. We are not dealing with only cavity, but mold is so complicated part, so that it is having ejector pin mechanism, it is having cooling mechanism, it is having again a sliding mechanism, it is having having number of core arrangements. See, mold doesn't mean only cavity, but mold is carrying all these number of things. That's why injection mold design is important and crucial part. If you see, or if you look at this figure, see product. I am moving the cursor, I hope you are getting. So I am moving the cursor on the product. This is the product. Okay. See how small is the size of product and how big mold is required for producing this product. So how it is operated: A plate, B plate, ejector plate, support plate, clamping plate. Now clamping is of different type: mechanical clamping, hydraulic clamping, or pneumatic clamping. Mechanical clamping is used for small products and small components. Sorry. Mechanical clamping is used for small products, small size of the injection molded product. Whereas hydraulic and pneumatic clamping are provided or used for larger size components. Now, this clamping plate is also important in this concept. Now, see here, I have shown 4 steps. Now, mold is in closed position, product is solidified. See, mold is in closed position and product is solidified. If you go to the next figure, what you observe here? One of the plate is opened. So this is a movable plate. This plate earlier it is closed here. Now you are observing it has moved. Okay. Now this is your product. I hope you are observing. I am moving the cursor on it. Okay. So here this is the ejector mechanism. As soon as this right hand side plate is opened, ejector mechanism will be operated automatically or manually. One more thing, it is your parting line. And see, what you observe here, this product is in touch with plate, mold plate. And now these pins are forcing this product out of mold. These pins are forcing this product out of mold. And now this product is out. And later on, product, where is product now? Product fall in the bin. And now mold is ready for next cycle. Product fall in the bin and mold is ready for next cycle. So I repeat once again. So now I will go by reverse way, next cycle. So this will be closed. There will be small gap. Then there will be injection through this point. Once there will be injection, you will again come back to this step. Now it is solidified. After solidification, it is opened. Ejector pin push and fall down. So opening, closing. Remember the sequence. Closing of mold, then injection, then cooling and solidification. Solidification start once, cooling will start. So closing of mold, injection, cooling, solidification, opening of mold, operating of ejector mechanism, and ejecting the component. These are the steps in injection molding process. So we have to remember all these steps and you have to draw all these figures in case of subjective examination. So just as a knowledge, you know that now exam will be objective, but otherwise you will miss this knowledge. You must know this in future. If you will join any plastic industry, you must know all these operations. You can take screenshots also. Second figure, I hope you are taking the screenshots. Third figure. Fourth figure. The injection molding is normally described by variety of criteria. Which are the criteria? So injection molding you can describe first by number of cavities in the mold. How many cavity mold is there? How you can describe the injection mold? So number of cavities in the mold. Then material of construction, which material is used? Whether it is stainless steel, whether it is tool steel, or whether it is aluminum or other material. Number of cavities in the mold, material for construction, whether next criteria is whether parting line is regular or irregular. Then next is method of manufacturing. How mold is made? Just by machining or casting. Then runner system in the mold. Then see, if you see the mold, the runner system is itself machined in that right hand side plate. This is a, see here I will show. This is a screw. There will be injection from this end, then gate system is provided, and which type of injection you are employed. So method of injection. Now this mold design, that's why carries important point, and weightage of mold design is more as far as the injection molding process is concerned. Now, as we have studied, the injection molds are defined by number of criteria. Out of that, one criteria was plates used during injection molding. So there may be 2-plate mold, there may be 3-plate mold. So one such 3-plate mold, typical mold, I will show you in the next figure. Three-plate mold. Please take screenshot. See here. If you look at this figure, 1 minute. If you look at this figure, this is one plate, this is solidified gating system. See, I am moving the cursor on it. This is your gating system only. This is not the product. So this is first plate, this is second plate, and this is third plate. And product is just above the another plate. So first plate is here, second plate is here, third plate is here. In between third plate and second plate, there is a gating system. And in between second plate and third plate, there is a product. So imagination is required. Assume that all these plates are closed. So when it will be closed, there will be gap. In this gap, this product will be produced. So these are the gates. See, this is one gate, this is another gate, this is runner, and this is the sprue. I repeat once again, this is the sprue, this is the runner, this is the gate. Okay, and this is the nozzle which is attached to the injection molded machine. And similarly, so plate will open 2 times. Once it open, between gap between first and second will give runner system to out, that is gating system, and gap between 2 and 3, that product will be out, and ejector mechanism will be somewhere here. That we have not shown here now. So you can take screenshot of this 3-plate mold. Three-plate mold. So we are studying experiment number 1. Title is Study of Fundamentals of Mold Design. So in Fundamentals of Mold Design, we have studied importance of mold in the injection molding, then different parameters such as cavities, material, gates, runners. Here, first important parameter we are studying types of molds based on number of plates. So if it is 2-plated, then it is 2-plate mold. If there are 3 plates, it is 3-plate mold. And remember, in 3-plate mold, the runner or gating system is between first, second, and product is between second and third. Now this classification or this type is as per the number of plates. Now here you are observing 2 cavities. This is first cavity, this is second cavity. There may be 1 cavity, there may be 2 cavities, there may be 3, 5, 10, 20. So single cavity mold and multi-cavity mold is the second classification. I repeat once again. Second classification is that single cavity mold and multi-cavity mold. So I will show that schematic diagram for single cavity mold and multi-cavity mold. I hope you have taken the screenshot of it. single cavity and multi-cavity mold. This is a schematic diagram. So these two views are shown, side view and front view. So if you see from front, or you can say top, whatever may be. So from front side, you are observing this is your cavity, and as your screw is perpendicular to paper, it is shown. But if you see from the side, this is the cavity, this is the gate, and this is the screw. I hope you are getting my point. Single cavity mold. This is the cavity, screw and runner is perpendicular to plane of paper, which is observed here in the left hand side. If you see here in the right side figure, there is multi-cavity mold. So this is schematic diagram. So this is one cavity, this is another cavity, this is third cavity, and this is fourth cavity. Screw is again perpendicular to plane of paper. And then these are the runners. Runners are parallel to plane of paper here. And then it will be directly here at joint of cavity and runner. There may be small reducible diameter size that may be gate. So you can see the difference between single cavity mold and multi-cavity mold. Please take the screenshot. Single cavity mold and multi-cavity mold. Now, let us see the runner system. There are two types of runner system. One is H-bridge runner system and another is star layout runner system. I repeat once again. First one is H-bridge runner system and second one is star layout runner system. What is H-bridge? It's very simple. All these are schematic diagrams. So you can see. I hope everybody is observing the cursor. So here this cursor is a screw. Screw is perpendicular to paper. Then 1, 2, 3, 4, 5, 6, 7, 8 are the cavities. So it will carry plastic in this side and again in perpendicular direction and it will reach to this cavity. So H-bridge system is again divided into 2-3 types. Simple one. Central screw, 8 cavities are filled. If it will be further modified as a conventional, again branching is increased. See, there is only one screw at the center. Hope you are observing this. There is only one screw at the center. This screw will carry the molten plastic to this. So 1, 2, 3, 4 branches are there and again 2 sub branches. It is improved design again. Number of cavities are increased. Check difference between first and second and third. Rebranching, more branching will be provided. All these types are called as H-bridge runner system. So simple, conventional and improved. Please take screenshots. Now this star layout runner system. If you see the difference in first one and second one, first one branching is perpendicular. Maybe 2 branches, 3 branches or 4 branches. All branches are perpendicular to each other in case of H-bridge system. Whereas in star layout system, you observe the central screw and the cavities are at the periphery on the circumference, and you will get 6 cavity, then 12 cavity molds as per the requirement. This is star layout runner system. H-bridge runner system, star layout runner system. Now, next one is the types of gates. We have studied manufacturing process in second year. So, types of gates, types of runners, little difference in the plastic components. So, directly screw is connected to cavity through the gate. It is called as a screw gate. Figure number 1. Then, edge gate. Your opening in the cavity will be from one side. Edge gate. Fan gate. Gate will be flat, and through the screw it is connected to the cavity. Then diaphragm gate. Diaphragm. So opening like circumference is provided, and opening will be more. Then film gate. Film gate is flat as like film. Last one is runner gate. Hope you have taken the screenshot. So figure 6 shows types of gates. So this experiment number 1, covers the fundamentals of mold design. Means how mold is important, then types of molds, the criteria for mold design, maybe number of cavities, maybe number of plates, maybe material used, maybe mass production, maybe gates used, and other parameters. So this is all about types of gates. Let us take the review in short. In today's fundamentals of mold design, what we have covered? We have covered the process of opening and closing of the mold and making of one simple component using there is operation of mold, operation of injection mold. How complicated the injection mold is, just don't see only cavity. Along with it, it carries heating, cooling arrangement, it carries clamping arrangement, it carries ejector pin arrangement. That's why injection molding process is, even you are getting, it is fast process, but there are a huge number of steps are involved into it. So these are the just steps. I am repeating it. Fourth one. So this is the 3-plate mold. So injection molds may be 2-plate or 3-plate. A typical 3-plate mold is as shown in figure. If you consider top as the first plate, then in between first and second, there is an injection mechanism, and between second and third, there will be the product, actual product. And then ejector mechanism is not shown here. Then we have seen single cavity mold, multi-cavity mold. Then types of runner system, H-bridge runner system, where the molds are arranged in perpendicular direction. And then R, next, simple, conventional, improved. And fourth one is star layout runner system. Star layout runner system, the mold cavities are arranged at the circumference. Okay. And then this is the gate, types of gate. So what is the outcome of experiment number 1? The outcome of experiment number 1 is, this is theoretical experiment. At the end of experiment, students will be able to study or explain the process of mold opening. Student will be able to explain the types of molds. Students will be able to explain different parameters of injection mold. Student will be able to explain different types of runners and gates. This is the outcome of experiment number 1. Okay, and you must study it sincerely so that there may be some MCQ question based on experiment number 1. That's why actually there is no as such separate syllabus of experiment for plastic engineering. Contents are from the same theoretical. Hence, we are studying in terms of the point of view as like getting extra knowledge, opening, closing of the mold. Unfortunately, we are not going in industry. That's why you are not able to see physically. But I have shown you different videos. You can also download different videos and check it. Okay, so just wait. Your exam will be probably on 5th May. Today's Sakal, the date is out. Please study hard. So friends, in today's class, we have covered fundamentals of mold design. Now already I have given 4 quizzes to you. And maybe next week one more quiz will be given. And it's my humble request. You can download the these notes which are available on the link. If there is any doubt, you can ask me based on the fundamentals of mold design. Is there any doubt? Okay, if no, then we will stop. Thank you.